Hey guys, hoping all is well with everyone. So in this video we're going to be looking at lesson 2.3, which is absolute values of rational numbers. So in the introduction of lesson 2 so far, we've kind of been exposed and introduced to this idea of integers and negative numbers. We've seen now the left side of 0 and the number line, and to be honest, these negative numbers have a really important role in a lot of real-world situations. For example, when it comes to finance and monetary exchanges and stocks, negative numbers play a big role in that. And then another one is kind of like geographical area, location, elevation, as well as sea level. So they play a really important role in particular um, situations in real-world problems. But what we're going to be looking at here is absolute value. And what absolute value is by definition the distance of value is from 0. So if there was a time where 0 was going to really be in the spotlight or really had its time to shine, this section would probably be the section that will really highlight 0's uniqueness as a number and its really important characteristics. The reason that is because it is kind of the fence line of the negative and positive numbers. So having that uniqueness of not having a negative or positive characteristic is pretty important. And the fact that absolute value looks at the distance from 0 makes it even more of a justice to its vitality as well. Okay, so looking at the solve and discuss it question, it says a portion of a bank account statement is shown below. How would you interpret the value of the ending balance? Explain. So, excuse me. If we look at the account statement, it says that the ending balance is negative $30. So keep in mind that a balance shows or represents to you the amount of available funds that you have at any given time from your bank. So what this kind of can be interpreted as is this person spent $30 more than what their available funds had for them at any given one time. But what it also means is that they would have to pay $30 just to break even at 0. Now keep in mind that 0 is again kind of the fence line of the number line, so it doesn't have a positive or negative component to it, which kind of brings us to this reasoning question. What does a balance of $0 mean? A balance of $0 means that you're not necessarily in debt, but at the same time you don't have any available funds that are usable. Okay, so it's kind of important to see that, again, 0 is kind of going to be the main focus of this section. So just to kind of reiterate, negative $30 as a bank account balance means that you're kind of in a debt to your bank of $30, okay, because you spent $30 more than what your account had available for you. So let's go ahead and look at the Focus on Math Practices question at the bottom. So it says reasoning. What is an example of a bank account balance that represents an amount owed greater than $40? So let's kind of look at that last part of that statement and focus in on that. So if we owed $40, then that would mean that our bank account balance would be negative 40.00. Okay, so what that would mean is that I'd have to pay $40 just to break even at 0. So I'm going to kind of represent this on the number line and kind of represent it that way. So if I have 0 here, well, I'll do negative 40 right here. So again, this represents the idea that I would have to pay $40 just to break even at 0. But the question asks me to have an example of an account balance that represents an amount owed greater than $40. The irony of this situation is that we're going to actually go more negative. The reason for that is keep in mind with negative numbers, the greater that you go negative, the smaller the number actually is. However, when we have in a negative balance, we're looking at how much we would have to owe, or we're looking at the distance that value is from zero. So when we were at negative $40, we only had to pay $40 to break even. But if we're at negative $50, we have to pay not $40 but $50 just to break even. So negative 50 would be an account balance that would represent an amount greater than $40 that we would have to owe. Okay, and again, that is because the distance from negative 40 to 0 is 40, and negative 50 to 0 is greater than that, being 50. Okay, let's go ahead and jump into example 1 here. So this question says to, or example 1 has us describe quantities using absolute values. So stock prices rise and fall during the year. The table shows the overall change in the price of the company's stocks from year to year. During which 2 years was the overall change in the stock price the greatest? So again, what we're going to do here is we're going to look at each of these changes in prices from 2012 to 2015 and see which one had the greatest change. So we're going to be looking at each one in particular, and that will help us to solve the problem. So what we'll do here is look at the year 2012. So the change in price was 6. So if we take the absolute value of 6, we'll get 6. If we take the absolute value of negative 34, the distance from negative 34 to 0 is 34. Now, one of the things that kind of, as you can see as a spoiler, is that the absolute value of a number is always positive. And that's because it's a distance. Now, I'm going to go ahead and put these last two numbers in, but then I'm going to explain that a little bit more. So the absolute value of 19 is 19. It's 19 units to the right from 0. And then the absolute value of 11 is 11. So the one with the two with the greatest changes in price in the year was, this was the greatest change. And 2014 was the second greatest. Okay. So even though the change in price in 2013 was negative 34, the change in its price in terms of a distance is $34, because that's a distance from 0. Okay, so going more into absolute value, always having to be a positive number. There are several units of measure in the world that cannot logically be negative. They would just be a mathematical impossibility. So even like in a certain word or story problem, maybe like in a math book or something, it may be possible. But if we look at things like a person's height, or a volume of air, or a distance, those 3 units of measure are things that can't be negative. You can't have a person that's negative 5 foot 3 inches tall. I'd be really kind of, I don't even know how I would think about that, but I'd be kind of worried if someone was negative 5 foot 3. But as another example, I can't blow up a balloon with negative 2 liters of air. So you kind of get the idea there that there are certain units of measure that just can't physically be negative because of what they measure. Okay, so that just kind of goes into a little bit of why absolute value is always positive, because it's a distance. You can't run negative 2 miles, you know. Alright, so this next part also shows that opposites, or 2 opposites, will always have the same absolute value, and that's because they're the same distance from 0. So remember, opposites are 2 numbers, but their signs are different. So for example, here they use 5. Positive 5 and negative 5 are opposites. So remember that the sum of two opposites is equal to 0. But more importantly, their absolute values of their individual selves are equal to the same amount. So the absolute value of negative 5 is 5 because it's 5 units from 0. The absolute value of positive 5 is 5 because it's also 5 units from 0. So it's kind of what this look for relationships question or statement says. It's opposite numbers have the same absolute value because they're the same distance from 0. And then this just shows the kind of approach that we took in the very beginning question. You can definitely use a number line as well. So if we wanted to do that, you can plot each of these and see their distance from 0. So this one, again, will show the greatest change because it's the greatest distance from 0. Okay. Alright. So the 2 years were 2013 with the greatest change and 2014 with the second greatest change. Alright. So here's the try it question. So it says the students in a science class recorded the change in the water level of a local river. During which week did the water level change by the greatest amount? Use absolute values to represent the change in the water level. So what we're going to do here is we're going to take the absolute value of each of the changes in the water level from each week and see which one gives us the greatest change. So for week 1, the absolute value of negative 7.5, again, when you see those absolute value bars, just some introduction to some notation here, so these are absolute value bars, that tells us that anything inside of it is going to be kind of forced to be positive because it's going to represent that that value is a distance from 0. So this is going to be 7.5 inches as a change. Okay. For week 2, we have the absolute value of 2.2. So again, those absolute value bars will tell us that we're going to take what's inside of it and make it positive because it's going to represent a distance from 0. If it's already positive, no worries there. It's just, we don't have to make any kind of changes or anything. And then last but not least, the absolute value of negative 4.38 will be 4.38 inches. So if we look at all of these three changes, in water level, the week with the greatest change was week 1 with 7.5 inches. Okay. Alright. Looking at the convince me question. It says, can a number represent a greater change in water level than can a lesser number represent a greater change in water level than a greater number? Explain. So I'm going to highlight some of the key terms here, or key phrases. Okay, so although we're looking at water level specifically in this question, what it's asking you is it possible or will a absolute value of a number that is less than another number possibly represent a greater change in a water level than a greater number? So to kind of put that into a more visual sense, let's take one number that is negative and one number that is positive and see if it's possible for a number that is negative to be representing a greater change than a positive number. So the example that I'll show you is negative 10, the absolute value of negative 10 and the absolute value of 2. So, without absolute values being considered, negative 10 is a lesser number than 2. However, if you take the absolute value and represent the change in water level with those values, you will get that the absolute value of negative 10 is 10 and the absolute value of 2 is 2. And this will be a situation where the lesser number can represent a greater change because its absolute value is greater than the absolute value of the greater number. Okay, so although negative 10 is less than 2, their absolute values change the dynamic of the situation, where the change is greater in 10 than 2. Okay? Alright, I'm going to stop there for ending part 1. So we have introduced the idea of absolute values, kind of the definition of that it is a distance from 0, and because of that definition, it is always a positive value. And we've also kind of looked at how we can use absolute value to represent a change in a particular real world or story problem situation. As always, guys, if you have any questions at all, please don't hesitate to reach out. I'll be posting the next part of 2.3 very soon. But as always, guys, thank you so much for watching, and please take good care of yourselves. Talk to you soon.